In this video, I will show you how to calculate the resultant vector when you have two vectors that are acting together, even when the directions are not simply north, south, east, or west. I will be using this four-step process and this convenient graphing organizer. An airplane flies due west at 240 kilometers per hour. At the same time, the wind blows the plane west 40 degrees north at 70 kilometers per hour. What is the plane's direction and ground speed? Well, first of all, here comes my graphic organizer. Set up your chart this way. We have two vectors. We have the plane velocity, which we will record in this column, and we have the wind velocity, which we will record in this column. And the third column is for the combined effect called the resultant vector. So step one is to determine the magnitude and direction for each vector. As I'm using this chart, every time I write a direction, the theta, I am going to be using an angle that is measured starting from the positive x-axis and measuring counterclockwise. The plane flies due west at 240 kilometers per hour. So the magnitude of the velocity is just the speed. So 240 kilometers per hour. You know what, I'm just going to put kph. Okay, now we need the direction. Well, the direction is due west. So just think about this. Maybe I'll do it on the diagram. If the plane is flying due west, that's the same thing as a direction of 180 degrees if we measure from the east. So that's what I'm going to put for the direction on the chart. 180 degrees. Okay, let's do the same thing for the wind. Okay, the wind blows the plane west 40 degrees north, but what's the magnitude? 70 kilometers per hour. All right, so the magnitude is 70 kilometers per hour. Now the direction said west 40 degrees north. So let's sketch that. West, let's see. If I say west 40 degrees north, that means start at west and turn 40 degrees towards the north. Okay, so this turn should be 40 degrees, and that's going to put the vector right here. Now, on the chart, I need an angle that is measured from the positive x-axis like this. Okay, so this angle should be 180 minus the 40. So of course that is 140 degrees. So that's the angle that I'm going to put on this chart. 140 degrees. So that's step one. We now have the magnitude and direction for each vector. Step two, convert the magnitude and direction to component form using our cosine theta and our sine theta. Okay, so I need component form. Now look, when I'm dealing with a quadrantal angle like 180 degrees, in other words, when I'm dealing with due west or north or south or east, I don't need to do r cosine theta or r sine theta. For the component form, this entire vector is the horizontal component. So because it's to the west, I'm going to say negative, and the magnitude was 240. So I'm going to simply say negative 240 for the horizontal component. There is no vertical component because the whole vector is horizontal. So I'm going to put 0. Okay, now however, when I move on to the wind, all right, this is in the second quadrant. So I will have to use r cosine theta and r sine theta. When I say r cosine theta, I mean 70 cosine 140. And then r sine theta, so 70 sine 140. So I can evaluate this using a calculator. And here you go. So I have negative 53.62 and I have 45.00. I have to round up, so because this is 99, this is going to roll over to 45. Okay, so here's my component form for the wind. So that's it for step 2. Step 3 is add the vectors to find the resultant in component form. So I just need to add these together. So I'm going to add the corresponding components, so negative 240 and negative 53.62. I'm going to add those. And then I will add the 0 and the 45, which of course will be 45. So I got negative 293.62 and of course 45. So that is my resultant. So now I just need to do the fourth and final step, which is to determine the magnitude and direction of the resultant. So I'm going to take this and I'm going to find the magnitude and the direction. Let's start with the magnitude. Magnitude is easy because we just use the magnitude formula. So I will do negative 293.62 squared plus 45 squared, and I'll take the square root of all of that. Calculator. I got 297.05. So that is the magnitude of the resultant, all right, kilometers per hour. That is going to be the overall speed of the plane combined with the wind effect. But I still need to find the direction. So let's consider this diagram. Because I have negative 293.62 and positive 45, that means we are dealing with a west direction and a north direction. In other words, we are in the second quadrant. So draw your vector in the second quadrant. Now let's consider the horizontal and vertical components. Okay, the negative 293.62 horizontal component and 45. All right, vertical component. So we can use these values to find the measure of this reference angle. So what we're doing now is we are finding the direction. So let me label my work. All right, we were to find the magnitude and now the direction. And I know that the tangent of the reference angle is equal to 45 over negative 293.62. However, I am going to erase the negative sign because I only care about the positive value of r. So the reference angle will equal the inverse tangent of 45 over 293.62. Calculator. That is 8.71 degrees. Now normally I would find the direction by measuring the angle from the positive x-axis. How far is it from east going counterclockwise? And we call that theta. And that should equal 180 minus the reference angle. that would tell me that the direction is 171.29 degrees, and maybe I'd write that down as the direction of my resultant. 171.29. So 171.29 degrees. However, I have to consider the form of the direction that they gave me in the original problem. However they described the direction in the original problem, I need to write my final answer using the same format. So they gave us directions like west, 40 degrees north, like that. So I need to convert this over to this format of direction. Okay, so how will I do that? Well, I don't want to do any more calculations than I have to. So I already have this reference angle figured out. So if I start at west and I turn 8.71 degrees towards the north, that would be the same thing. So how's that again? I started at west and I turned 8.71 degrees towards the north. So this is another way that I could write the direction. Okay, so I'm actually going to rewrite the whole thing because I like my final answer to be all in one place. So this purple is how you should write your final answer. So magnitude and direction, 297.05 kilometers per hour. That's the magnitude. And the direction, west 8.71 degrees north. West 8.71 degrees north. Kabam! There's your final answer in the box. Let's do one more problem on this video. So forces with magnitudes of 125 newtons and 300 newtons act on a hook. So obviously this is the 125 newtons, the 300 newtons. The angle between the two forces is 45 degrees. Find the direction and magnitude of the resultant of these forces. Okay, and we might as well just use the directional set of axes that they gave us. In other words, as I look at this, I'm going to treat this as the x-axis, and I'm going to treat this as the y-axis. Okay, so we could organize our work like this onto the chart. So we have the two different forces. Let's record the magnitude and direction for each force. So the first force has a magnitude of 125 newtons. So we can just write down 125 newtons. And it has a direction of 45 degrees that you can see from the diagram. So I'll just write down 45 degrees. All right, this is the angle that is measured counterclockwise from the positive x-axis. So this is the angle that we want for the chart. Now for the second force, the magnitude is 300 newtons. So we can write that down. The direction is just due east. So in terms of an angle measured from the positive x-axis, it is the positive x-axis, also known as 0 degrees. Now let's do the second row. Let's convert both of these into component form. If I have the magnitude and direction and I want to convert to component form, I use the formula r cosine theta and r sine theta. So for the first force, if I want to do r cosine theta, that's just going to be 125 cosine 45. R sine theta is 125 sine 45. And we can evaluate this with a calculator. So here we have the horizontal component and the vertical component, which I will record here on the chart. Now, when I'm dealing with force 2, I'm not going to do r cosine theta and r sine theta because the second force is horizontal. It doesn't have a vertical component, only a horizontal component. So the entire 300 newtons is going to be the horizontal component. So that's why I'm going to have 300, 0. All horizontal, no vertical. And it's positive because it's going to the right, to the east. Now, we need to find the resultant by simply adding these two vectors together. So the resultant vector is this. It's simply 388.39 horizontally and 88.39 vertically. Now, we need to find the magnitude and direction of this. That's the piece that is missing. So off to the side, let us calculate the magnitude and the direction. Okay, so first of all, the magnitude, see we have a lot of space up here, so I'm going to do the magnitude. And then I will calculate the direction. For the magnitude, I can just use the magnitude formula. Looking at the component form, for the magnitude, you just square those components and take the square root, and then there's your magnitude. So I'll record that right here. So we have 398.32, and let's check what the units were, newtons. Okay, now let's talk about the direction. So let's make a little graph to help us out. So look at these components. It's east and north. It's to the right and up. So that means we are dealing with the second quadrant, like this. So then we've got the horizontal and the vertical component. So the horizontal component is the 388.39, and the vertical component is our 88.39. So we can easily find the direction, theta, using tangent. So the tangent of theta will equal 88.39 over 388.39. So that means theta will equal the inverse tangent of 88.39 over 388.39. Calculator. That is 12.82 degrees. 12.82 degrees. So that is it. That is the magnitude and direction of the resultant force. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.